All right, chapter P, section 5, part D. This is the last part of our prereq stuff. We're going to talk about rational expressions, adding and subtracting, inside of complex fractions. So all it is, guys, honestly, is just a couple complex fractions. I mean, a couple adding and subtracting rationals inside of a fraction. That's it. Two options. Option one, you can find the LCD of the fraction, multiply each term by that LCD, then simplify. Or you can find the LCD of the numerator and denominator separately, then keep, change, flip. That's what I like to do. Some of you are looking at that like, what? I don't understand. It's fine. I'll show you. I like to do option two. If you like to do option one, if someone taught you option one, some last period, somebody's like, oh, I went to my tutor and they did this. That's fine. As long as it makes sense to you, that's fine. So here we go. What we're going to do is we are going to simplify the numerator. We're going to simplify the denominator. Then we're going to keep, change, flip. So what I mean by that, these first few are pretty simple, pretty straightforward. So do you guys see that right here? All right, so you have a fraction here in a numerator. God bless you. Everybody see that? And then we have a fraction here in the denominator. So all we're dealing with, guys, is going to be two fractions inside of a fraction. How do you divide fractions? You keep, change, flip, okay? So what we're going to focus on is simplifying the numerator, simplify the denominator, then keep, change, flip. Is your numerator simplified? Is there anything to add or subtract in my numerator? No. Is there anything in the denominator to add or subtract? No. So we're just going to keep, change, and then flip. X squared comes on top, and 1 goes on the bottom. Everybody with me? So what can I cancel out? Okay, this x and 1x up here, so I'm left with just x. That's all we're doing today. We're going to simplify a numerator, simplify a denominator, keep, change, flip. The first few are quite simple, right? Look at number 2. Does everyone see this fraction here in the numerator? This fraction here in the denominator? And we're dividing these two. So look at your numerator. Can I simplify anything? No. Do I have anything to add or subtract? No. Look at your denominator. Can you simplify? Yes. You don't have to do it right this second, but if you wanted to, what would it be? X minus 2 and x plus 2. Okay, perfect. So we're going to keep, change, flip. I'm going to keep 1 over x minus 2 times, when I flip, what does my numerator become? X minus 2x plus 2 over 1. Now this becomes a multiplying problem that we've done a few times already. What can I cancel out? The x minus 2 is perfect. And what are you left with? Just x plus 2. Questions? All right. Let's look at number... Oh, it's on the next. Let's look at number 3. All right. When you look at this problem, what do you guys immediately see? X squared minus 9, which gives you? X plus 3, x minus 3. Good. So I'm glad that you guys are starting to see that. So let's go ahead and simplify my numerator. I have 1 over x plus 3, x minus 3, right? Do I have to simplify anything in the denominator? So I'm going to keep, change, flip. This becomes x minus 3 over 1, correct? Anything in top and bottom that's exactly the same. X minus 3's, okay. What are we left with in your numerator, guys? There's a 1 over x plus 3. Don't forget, if something cancels, if everything cancels, it does not mean there's nothing there. There's always a 1 left. All right, so now we're going to get to some that are a tad bit more complicated. Do you understand? Do you guys see that there is a rational expression in the numerator? Right? This is over 1, correct? This is over 1. We have to simplify that before we keep, change, flip. We cannot just keep, change, flip how it's written. We've got to get a common denominator. So I'm going to deal right here in green with just my top. What is a common denominator between x and 1? x, okay? So this is what we did yesterday. My first fraction has the x in the denominator. Do I need to do anything to it? So I have 2. My second fraction, I have to multiply the bottom by x. That means I have to multiply the top by x. So this becomes minus 3x. Everybody with me? Okay. Divided by, now I'm going to do the same thing with my denominator. What is my common denominator between 1 and x plus 1? Sorry, x minus 1. Look at the fraction at the bottom. We're looking at the denominator. What's my common denominator between 1 and x minus 1? X minus 1, okay? So I'm going to write x minus 1. So look at your first piece. What do I have to multiply the denominator by so it looks the same? X minus 1. What you do to the bottom, you do where? Okay, so I have x minus 1. Then what? X minus 1. Finish the problem, guys. X minus 1. And then what? Minus 1. I didn't have to do anything to the second fraction. Now we can combine. What can I combine here? Negative 1 and negative 1 gives you? Okay. So I have 2 minus 3x over x divided by x minus 2 over x minus 1. We have not completed this problem. All we've done is just simplify the numerator and simplify the denominator. Okay, have we completed this problem? No, all we've done is just simplify the numerator and simplify the denominator. But now, can I keep, change, flip? Yes. As long as you have a common denominator in the top fraction and a common in the bottom, you don't have anything else to add or subtract, now we can keep, change, flip. So I have 2 minus 3x over x times, and when I flip, what does this become? X minus 1 over, say it again, x minus 2, okay? All right, so now we see, okay. Is there anything that is in common that I can go ahead and cross out? No, so do we immediately think we did something wrong? No? None of you thought, oh, I must say something wrong. Okay, good. That's it. You cannot combine anything. It's just 2 minus 3x times x minus 1 over x times x minus 2. A lot of the times, something will cancel, but don't freak out if you get to a point where it doesn't. Just go back and check just to make sure you cross all your T's and dotted your I's, that good stuff. Okay, we all right? Stop me if we're not. Okay, look at number 5. Is there anything in the numerator that I need to go ahead and simplify and combine? Okay, excuse me. So I'm just going to write x plus 5 over 1. What about my denominator? Is there anything to simplify? Yes. What's my common denominator going to be between 5 and 1? 5. Okay, I agree. So my x squared is just going to hang out, right? Minus, what do I have to multiply the 5 by? Good. If we multiply the bottom here by 5, then the top, so I have minus 25. Soon as you write that down, what do you think? Difference of squares. Good. Good. You guys got to start seeing that. Get in the habit of seeing that. So now I have just a simplified fraction divided by a simplified fraction. So we keep x plus 5 over 1, change division to multiplication, and then I flip. I get 5 over, and how can I factor that? Perfect. X minus 5 and x plus 5. Now, is there anything on the top and bottom that's exactly the same that we can cancel? Perfect. The x plus 5s. So your final answer, guys, is 5 over x minus 5. Is this horrible? No! Miss Rogers said yes. Well, you have too many words in your thing you do. All right, let's look at 6. Let's talk about 6. What do you guys notice about 6? Do I already have a simplified denominator in both of them? Okay, Luna says x squared minus 1. What is that going to factor out to be? X plus 1, x minus 1. Good. What does the bottom numerator say? x minus 1 squared. What does that mean? X minus 1, x. It means there's two of them. Good. All right, so we can go ahead, guys, and keep, change, flip. I'm going to keep x squared minus 1 on top, so it's x plus 1, x minus 1 over x. I'm going to change my division to multiplication. And then when I flip, I'm going to write this like this. X over, how many x minus 1s do I have? I have 2 because it's quantity squared. Good. So now, do you guys see a bunch of stuff we can cancel out? Yep, the x minus 1 and an x minus 1. Good, what else? X and an x, awesome. So I'm left with, in the numerator, x plus 1. The denominator, x minus 1. Good job. Good job, good job. Scooting along. Get a little more complicated, no big deal. Do you guys see how we have to do some simplification in the numerator and in the denominator? Okay, so let's deal with the numerator first. What is my common denominator going to be between 1 and x? X, agreed. So what do I multiply the 6 by? X, good. So I have 6x minus 5. Now let's look at the denominator. What's my common denominator going to be between 1 and x? X, good. So I multiply 1 times x, and I get x, so I have x plus 5. Everybody see how we just did that? Do I now have two simplified fractions that I'm dividing? Yes, so we're going to keep 6x minus 5 over x, change division to multiplication, and then flip x over x plus 5. And what can I cancel? The x. X on top, x on the bottom. Remember, guys, 6x is attached to negative 5. In the denominator, x is attached to positive 5, so you cannot cancel anymore. It's just 6x minus 5 over x plus 5. Remember to keep everything in parentheses. It'll help you. Whoa. First of all, if you don't like a's, what can we change it to? X, y, z, I don't care. I will never use b's in my own work because my b's end up looking like 6's and then I get myself confused. But let's deal with each thing independently. I'm going to deal with this numerator right here. What is a common denominator between a plus 1 and a? What did we do yesterday when we had two completely different denominators? What did we do to them? We multiplied them. If you had a 2 and a 3, you multiplied, got 6. Same thing here, guys. You can't just add a plus 1. The two common denominator would be a times a plus 1. So you look at each fraction independently. My first fraction has the a plus 1. What is it missing? An a. So a times a is a squared. My second fraction has the a. What is it missing? A plus 1. So I have plus a plus 1.
Wouldn't you put the a plus 1 in parentheses?
You can.
Because if it is, can you cancel?
Nope. No, because this plus, look, this right here, if you have it in a parenthesis, you can, but there's still a plus sign attached to it. Because you're adding a squared and a plus 1, you're not multiplying it. See how in the bottom it's being multiplied? A times, it's different because that plus sign's there. So look at the denominator, guys. If I look at my denominator, I say, okay, what is my common denominator between a and a plus 1? A times a plus 1. Okay, good. So look at each fraction independently. My first fraction has the a. What is it missing? A plus 1. My second fraction has the a plus 1. What is it missing? An a. Good. Can I combine here? What's a plus a? 2a. Okay, good. So let's just rewrite this. I have a squared plus a plus 1 over a times a plus 1 divided by 2a plus 1 over a times a plus 1. Have I now simplified as much as I can each fraction independently? Yes. Now we keep change flip. So a squared plus a plus 1 divided by a times a plus 1 times, when I flip, I have a times a plus 1 over 2a plus 1. Anything exactly the same on top and bottom? The a and the a plus 1 and the a plus 1. Can you guys factor a squared plus a plus 1? Are there factors of 1 that multiply to give you 1 and add to give you 1? No. So you just are left with a squared plus a plus 1 divided by 2a plus 1. Stay with me. 2 more. Stay with me. All right, last two. Again, do you guys see how there's 2 adding and subtracting rational problems? There's 1 in my numerator and 1 in my denominator. You have to simplify those independently and then go ahead and divide. So put a 1 underneath so you don't forget that that's your denominator. But in my numerator, what's my common denominator between 1 and x? X, perfect. So my first piece, my first fraction has a 1. What does it need? The x. If I multiply the bottom by x, then I multiply the top. So I have 2x minus 2. Everybody agree? We okay? All right. Here's my big division sign. In my denominator, what's the common denominator? X. Good. So I multiply this 2 by what? An x. So I have 2x plus 2. I now have 2 simplified fractions, 1 in my numerator, 1 in my denominator, that I can now keep, change, flip. So I'm going to keep 2x minus 2 over x, change my division to multiplication, and then flip x over 2x plus 2. What cancels? The x, good. Can I just randomly cancel 2's? No, let's go ahead and watch this, guys. 2x minus 2 over 2x plus 2. In order to simplify, take out the GCF. What is the GCF in the numerator? 2. So I have 2 times x minus 1. What's my GCF in the denominator? 2. So I have 2 times x plus 1. Now what can cancel? Now we can cancel the 2's. Good. So here's your answer. Don't just start randomly crossing off. Oh, I see 2's in the numerator, 2's in the denominator. You have to wait until you simplify everything and then take out the GCF. Yeah.
Can you simplify downstairs?
All right, let's look at the last one. Is my numerator a simplified fraction with 1 denominator? No. So let's go ahead and get that there. I have x plus 3, and I have an x. What is my common denominator between x plus 3 and x? X times x plus 3. Remember, we said yesterday, it's so much easier when they're completely different because you just stick them together. So then we look and say, okay, my first fraction has the x plus 3. What's it missing? X minus, don't forget that minus sign. My second fraction has the x. What is it missing? X plus 3. Okay, pay attention to this, guys. What does that minus sign mean? I have to distribute. Don't forget that, because when I distribute here, I get x minus 3. What's going to happen to your x's there? They're going to cancel. Good. What are you left with on top? Negative 3 over x times x plus 3 divided by 1 over x. Now, do I have 2 simplified fractions that I can divide? Yes? Okay, so we're going to keep negative 3 over x times x plus 3, change division to multiplication, and then flip x over 1. Anything exactly the same in numerator, denominator? An x? Good. So you're left with negative 3 over x plus 3. Now, if you forgot to distribute that negative, you guys would have gotten 3 over. And it's not a matter of I forgot to put the negative sign. That's a huge mistake if you forget to distribute a negative throughout the problem. So just pay attention to stuff like that. Sure. I want to go over one more problem because last period started their homework and everybody came out to ask me this web assign question. So I'm going to go over it with you. All right, let's look at this. Let's look at this. So you guys have, let's say, x to the 6th. Boys, listen, please. You should do all of the problems for extra practice. Probably really good for you to do. Do whatever the homework says on Canvas to do. So x to the 6th, and then say x minus 4 to the 4th power, divided by x to the 3rd over x minus 4 to the 7th power. All right, this is a very, 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 very simple problem. There's no reason to complicate this at all. Is there any rationals that you have to add or subtract? No, you don't have anything to simplify. So we're going to keep, change, flip. I have x to the 6th over x minus 4th to the 4th power times, when I flip, this becomes x minus 4 to the 7th power over x cubed. Guys, what does it mean x minus 4 to the 4th power or x minus 4 to the 7th power? What does that mean? There's 7 x minus 4s on the top, and there's 4 x minus 4s on the bottom. Everybody understand that? So you can cancel. What can we cancel out with the x's? Okay, I can take away 3 of the x minus 4s. Where are they going to be left? On the numerator. So it's to the 3rd power. What about my x's independently? I can take out 3 of them, so I'm left with 3 up here. So your answer here would be x cubed times x minus 4 cubed. That's all you have to do there. If you got, look, let me show you, write it out. I have 6 x's, 1, 2, 3, 4, 5, 6. And on the bottom here, I have x minus 4, x minus 4, x minus 4, x minus 4, right? Then I'm going to switch. I have 3 x's here. Why'd I make it 7? X minus 4, x minus 4, x minus 4, x minus 4, 1, 2, 3, 5, 6, and 7. So this is what this problem visually looks like. Anything on top and bottom that's exactly the same you can cross out. So I have 4 x minus 4s on the bottom. That'll cross off 4 x minus 4s on the top. So how many am I left with? 3 of them. Then I have 3 x's on the bottom. That'll cross off with 3 on the top. So I'm left with 3 of them. So that problem is super simple, guys. It's just written funny because it's a quantity squared. It's not just one term by itself, but it's very simple, very basic. Does that make sense? Okay.